Time for the third moment of your distribution, and I went into Google Gemini and I asked a question and I wanted to just maybe have a little bit of fun with this one. Google Gemini came up with this formula for me. I have seen it before. It's maybe not technically quite as correct, but it's nice to kind of just see what's out there and what's maybe good enough. So this is what we're going to go with for your exercise as an insurance pricing agent. To calculate the skewness of a homemade data distribution, which is what we're working with, you can use the following formula. Skewness equals 3 times mean minus median, all divided by standard deviation. So we are going to play around with that formula and, see what comes up. All right, that formula, just very quickly, it's the skewness, the third moment, and we're going to work with the shortcut version. It's going to be 3 times the mean, the expected profit, minus the median value, which will be fun to kind of think about, all divided by the standard deviation. Let's have a go. Okay, great. It's your turn to calculate skew. Now, just to kind of provide some variety, unlike the last central moment page where we locked you out of those figures, we wanted to keep those constant. Here, we're going to let you go in and play around and tinker. Not that one way is better and the other way is worse. There's kind of like some pros and cons to each, but we just wanted to give you the chance to get back in and get your hands dirty if you wanted to change up some of these probabilities or profit outcomes. Remember that formula. It's going to be 3 times the mean minus the median, all divided by the standard deviation. Well, we do have a standard deviation calculated. We do have a mean calculated. So what we're missing is the median, right? Like, what are we going to do? And we're not working with actual data. So you can't just go through if you don't have the data and say like equals median. What you need to do is you need to go down this column and ask, where does the sum get to 50% or, like in the neighborhood of 50%? And in our particular case, by the time we even get down to the second to last value, we've still only accounted for 20.41% of all of the probabilities, which is to say that definitely for our scenario, the most likely outcome is the one where we just sell the insurance policy and we keep the money, like there is no event, and that happens to be $22,000, what we've charged for our insurance. That happens to be the median value. If we made some of these other values more likely, well, then it would change the medians. I'm going to make this 10%, 10%, 10%, and you can see now that this is kind of changing things where the base outcome where I just kind of make money is falling, falling, falling. Well, let's do the same exercise. Let's head down, let's add, and let's say, okay, looks like we're not quite there. We're right at 50%. So 50% above, 50% below. And so maybe now it's going to be negative 30,000 would be our median. That's basically how you would massage through your homemade distribution, your homemade scenario, and you would figure out what the median value is. You're going to put in that median. And then from there, you're going to calculate skew as saying 3 times the expected value minus the median value, all in parentheses, divided by the standard deviation. In this case, we have a negative skew of negative 0.75.